Welcome back to Algebra 1 with Miss Betsy. Today we are going to be talking about how we translate word sentences into equations and solve them to find an unknown quantity. This is something that you'll be using continually when you work with word problems in Algebra 1, Algebra 2, pre-calculus, calculus, all of these other mathematical classes that you're going to be taking. You're going to be solving real-life problems where you have to translate from English into algebra. So that's what we are going to be working with today. This is my text. This is Algebra 1 for Christian Schools, published by Bob Jones University Press, and I'm using the second edition. It's not the same as the third edition, so those two are not compatible, but you can still learn about how to work with word sentences and equations regardless of what you're using for your text. So let's go ahead and pray. I've got a lame joke for you and then we'll get started. Oh, Father, you are good, and I am so grateful for your presence in my life. Father, I ask that you would help us to bless us with the ability to stay focused and to be disciplined in our coursework and in our daily lives, Lord, so that we're able to accomplish those things that you intend for us to accomplish, and so that we're able to understand our studies and continue learning things that our parents want us to learn, things that we are curious about, and things that you are directing us to learn. Father, I thank you that you are active in our lives, and I pray all of these things in the name of your Son, Jesus. Amen. Last joke that I have on my card here, I'm going to have to go get some more. What do you call an elephant with wings? And no, it's not Dumbo, because Dumbo's wings were his ears, so he had ears. This is, what do you call an elephant with wings? Well, you call that a jumbo jet. So, I don't know that they necessarily call the jets jumbo jets anymore, but 747s I think they used to call jumbo jets. So anyway, word sentences and equations. And they have a lot of examples here in your text for those of you who are using this book. You're going to want to make sure that you go through it and pay lots of attention, that you understand exactly where they're arriving at their equations from. But it's really pretty straightforward. I think probably your key thing to consider when you're working with translating word sentences and dealing with equations is that don't try and take too big of a piece at a time. It talks about, on page 121, what do you do to translate words into equations? You read the problem carefully. And the carefully right there is the key thing to consider, because we tend to run our eyes real rapidly over sentences and we miss things. Secondly, it says to analyze the problem, and analysis involves taking enough time to pick things apart and to consider what your problem is actually telling you. Once you've been careful to read it the whole way to the period, don't read it part of the way through. Decide that you know what the problem is asking for you and then stop. But read the whole way to the end of the problem. Think about it, analyze it, see what they're trying to find. Substitute algebraic symbols for words, which is what you've been doing when you're learning how to translate English into algebraic expressions. And then you write the equation. So, let's go ahead and, this is pretty bad if I'm going to check my text, but that's only because I'm waiting for my husband to get home from work. All right. The sum of a number and 5 is 23. Find the number. So they want to know if you can translate this word problem into an equation, and they call it a numerical equation, and I'm not sure why they're calling it a numerical equation, because they're talking about the number. So it says first, analyze it very carefully. The statement, find the number, tells you that the variable is going to stand for the number. So this is actually an algebraic equation if we're being technical about it. Numerical equations don't contain variables. Algebraic equations do. So statement find the number tells you that the variable will stand for the number. So you're going to choose a letter as a variable to represent the number. A lot of people use n, they're going to tend to use x, and I'm going to tend to use x here. So we're going to say our problem is the sum of a number and 5 is 23. And 5 is 23, and they want us to find the number. This is our problem. So we have to come up with a variable that we're going to use for the number, and they said, okay, let's just let x be the number. So we're going to say let x be the number. Now what are they asking us, or what are they telling us? They're telling us that the sum of a number and 5 is 23. So what mathematical operation does sum indicate to us? Well, it's addition. So the sum of a number and the sum of a number and 5. And they're just jotting down some thoughts here. Okay, what is it? What does is mean? We just said that is represents an equal sign. So that's going to be our equal sign. So we're going to have the sum of a number and 5 is 23. So we're going to put all of this together into a sentence. The sum of a number and 5 is 23. This is the algebraic equation. This is a translation of the sum of a number and 5 is 23. This is nothing new to what you've been doing. You've been working with the sum of a number and 5 forever. Is simply an equal sign, and there's your answer. So this right here is what we call an algebraic equation. And the equation algebraic, the fact that it's an equation tells us that it is separated with an equal sign, which tells us that the value of what we have over here on the left of this equation is the same as the value that we have on the right of the equation. So that's all they're going to want you to do. You've read it, we read it, we analyzed it, we considered every piece of information that was given to us, and we were able to write the word sentence, go from a word sentence into an algebraic equation. So let's look at some more. Now, at this point, are they asking us to solve these? No, they're not asking us to solve these yet at all. And I don't really think, let me remember, we're not going to be solving any of these problems. Do not solve problems in this chapter. All that we're doing, in this section, all that we're going to be doing in section 3.9 is continuing our work with translating from English into algebra. So we now have another example that we're going to look at. This one is involving the difference. What is difference talking about mathematically? Well, difference is talking about subtraction. So this is example 1. The difference of a number and 10 is 37. The difference of a number and 10 is 37. So they want us to come up with a number. That means first we have to come up with a variable that we're going to say. And I'm just again going to go with x. Let x equal the number that we're trying to find. Now, what pieces of information do we have given to us in this problem? Well, we have difference, which we already indicated was subtraction. So maybe you want to write down that difference is subtraction. These are notes. You do not have to write all of this down. The difference of a number and 10. So we're subtracting 10 from that number. So x minus 10. We have is, again, that's going to be our equal sign. So the difference of a number and 10 is 37. We include the equals 37 here because it's part of our English words, is 37. What we have on the left-hand side of this equation here, a number minus 10, is 37. In other words, it has the same value of 37. This is all they want you to do. They translate from the English into algebra. Okay, now we have example 2. And this says, if 23 is added to 4 times a number, the result is 143. If 23 is added to 4 times a number, the result is 143. So what do we want our number to be? We want our number to be a variable. Here they're picking n. Pick any letter you want. So we'll just say, let n equal the number. What else are they talking about in our problem? 23 is added. Well, we know we're going to have addition. We're going to add 23 to something. What are we going to add 23 to? We're going to add 23 to 4 times the number. So 4n would be 4 times the number. And we're going to add 23 to this. So we're not going to say 23 plus 4n, because this says 4n is added to 23. Now, even though I said addition is commutative, it means the same front and back, I want you to literally translate from your English into your algebra. So we're going to add 23 to 4 times the number. So we have 4n plus 23. The result is what you end up with. That means equals. The result is 143. This is all that they are talking about. They want you to come up with the equation. The equation is balanced. It says this value on the left, 4n plus 23, is the same as 143. All right, let's look at example number 3. And this is at the top of page 121. It says 6 subtracted from 3 times a number equals 36. Equals 6 subtracted from 3 times a number equals 36 decreased by 4 times the number. And then they want you to find that number. This, my friends, is quite a mouthful. Not find the numbers, find the number. Now remember I said at the beginning that we want to be very careful to analyze our problem. 6 subtracted from 3 times a number equals. This is where we're going to have the break in our math, in our algebraic sentence. That's where our equal sign is going to be. Everything that comes before the equal sign is going to be on the left. Everything that comes to the right of the equal sign is going to be on the right-hand side, or everything that comes after the equal sign. So let's pick this apart, a phrase at a time, and see what we have. We have 6 subtracted from 3 times a number. Well, we need a value for the number. So let x equal the number. We see that we also have 3 times the number, so we're going to have 3x is 3 times the number. 6 subtracted from 3 times the number. So what comes first? 3 times that number comes first, and then we're going to subtract 6 subtracted from 3 times the number equals. Right, we're done with the first part of our equation. Equals 36 decreased by, now what does decreased by mean? It means subtraction. Equals 36 decreased by 4 times the number. 3x is 3 times the number. What is 4 times the number? That's right. Decreased by 4x. This one is longer. It has a lot more going on in it than what we have done before, but you still take it apart one piece at a time. You figure out where the breaking point or the dividing point is in your English sentence by looking for that equals. This is all they want you to do. They don't want you to solve it. They don't want you to say that 7x is equal to 42, so x is equal to 6. I can do that because I know where it's going, but they're not asking you to solve it. They only want you to write, see now I'm wondering if I got it right, 36 minus 24, 18 minus, yeah. They only want you to write the equation. That, my friends, was a rabbit trail for the teacher. Sorry about that. Now, let's look at example number 4. And this is a very important one because we're talking about consecutive integers. And let me look in the homework. I don't remember if that has consecutive odd or consecutive even integers in it. Consecutive odd integers. Yes, they do. I want to talk about this as well. Okay, we are now in example number 4. Example number 4 says the sum of 2 consecutive integers is 49. Find the 2 integers. So let's step back from this for a moment and see what it is that we're going to need to be doing. We have the sum of 2 consecutive integers. First off, what's consecutive? Things that are consecutive is one right after another. So if you have consecutive integers, it would be like 1, 2, 3, 4, 5. Those are consecutive. They are one right after another. What comes after 5? 6. How did you get 6? You added 1 to 5. What comes after 6? 7. Because you added 1, you add 1 to 7, and you get 8. And that increasing step by adding 1 to get to the next consecutive integer, that is crucial, key piece of information in setting up this problem. Because what we're going to say is let x equal the first integer, and x plus 1 is the next consecutive integer, or the second integer. The next consecutive integer. X and x plus 1. Crucial piece of information that you know that this is how you set up when you're dealing with numbers that are consecutive. Consecutive, you just add 1 to the first. Now, what does it say? It says the sum of two consecutive integers. So the sum of the first integer plus, the first integer plus the second integer is equal to 49. This is what they're looking for. The sum of two consecutive integers, x plus 1 is 49. Let's go ahead and look now at example 5. This is on page 121 as well. One number is 6 more than 3 times another number. Then 3 times another number. The difference of the numbers is 34. Difference of, I got lost there, the numbers is 34. What are the two numbers? Now this one is involved. If you read this, one number is 6 more than 3 times another number. The difference of the numbers is 34. What are the two numbers? You can go, can't do it. So you take it a phrase at a time. It's like that silly joke. How do you eat an elephant? You eat an elephant one bite at a time. You work with these more difficult translations from English into math one bite at a time. So we're going to just pick a variable. We're going to say, let x be the number, or let the number be x. And it says that one number is 6 more than 3 times another number. So we've got, here's our first number. The second number is 6 more than 3 times the other number. Here's 3 times the other number, and here is 6 more than. This is the other number. Remember I said with more than, less than, it helps me to read it backwards. But you have to look at problems like this and make sure you know what number you're beginning with. We're not beginning with 6. We're beginning with 3 times a number, and we're adding 6, so we have 6 more than 3 times a number. This right here is the way that we're going to use our variable for both numbers. Now, the difference of the numbers is 34. What is difference? Difference is subtraction. The difference of which numbers? Which number do you subtract from the other number? We're going to assume that we're going to subtract from the first number. The difference of these two numbers, and let me see if that's actually what they did. Okay. Subtraction, you know, is not commutative. It does not mean the same thing going both ways. One number is 6 more than 3 times another. The difference of the numbers is 34. What are the two numbers? And I think the reason we're not going to say x minus 3x plus 6, we're going to listen very carefully to how this is phrased. One number is 6 more than 3 times the other. This is the one that is mentioned first. The number that is mentioned first is the one that is 3 times as big as the other number plus 6. So you're going to have to subtract the second number from the first number. So we have the first number, and go ahead and put it in parentheses. It makes it clear that you are taking every bit of that information, the 3x plus 6, to describe the number. Difference is subtraction. The difference of the numbers is 34. This is the first number that is mentioned. It's 6 more than 3 times the other number. This is what they want you to have. Don't get frustrated with these. It takes a little bit of time, a little bit of practice until you get to the point where you are comfortable translating from English into algebra. Okay? And I said I wanted to do one more thing from our from the examples, not from the examples, from the homework. I showed you what to do if you had consecutive integers, and that's where the first integer is x, and then x plus 1 is the second integer. But what if you have consecutive odd and consecutive even integers? Even integers or consecutive odd integers. How are we going to indicate those? Even integers would be 2, 4, 6, 8, and so on, right? So how do we get, we've got even integers, how do we get from 2 to 4? We added 2. How did we get from 4 to 6? We added 2 again. How do we get from 6 to 8? We add 2. What's our next integer going to be? It's going to be 10, and we get there by adding 2. So you see that this is a similar pattern. We say, let x be the first number, x plus 2 is the next consecutive, even integer. Doesn't matter which one we start with. We know that if we just add 2 to that number, we'll have the next one. If we're up at the integer is 100, well, 100 plus 2 is 102, which is the next consecutive even integer. Remember, even integers are those numbers that can be evenly divisible by 2. So this, you should be writing this down and memorizing this. This will show up. Okay? Consecutive odd integers. Well, if we added 2 for even integers, you might think, well, we're just going to add 1, or we're going to add 3 for odd integers. And if you think that, you'd be incorrect. Let's look at this pattern. These are odd numbers, right? 1, 3, 5, 7. They're not evenly divisible by 2. How did we get from 1 to 3? We added 2. And from 3 to 5, we add 2. And from 5 to 7, we add 2. So even though it might mess with your head a little bit, because you're dealing with consecutive odd integers, we're going to say let x equal the first number and x plus 2 is equal to the next consecutive odd integer. So the fact that we have even integers and odd integers does not play into how we identify with them with the variable at all. What we're looking for is the pattern to get to the next one of them, whether they are even or odd. To get to the next one, we're just going to add 2. So make sure that if you don't understand this, that you at least write it down and work, chew on it for a while, because you will have problems forever dealing with consecutive even integers and consecutive odd integers. That's the end of chapter 3 and of section 3.9. If you have questions, send me a text, or I will see you in class on Friday.